Hi everyone, my name is Donny Lopera, and today I'm going to talk to you about solving linear equations using matrices. Matrices were invented by the ancient Chinese around the 300 BC as an important mathematical tool. During the 1600 to 1800, great mathematicians had contributed to the development of matrices. But the term matrix was introduced by the English mathematician and lawyer James Sylvester in the 1850s. Matrices have many applications in science, engineering, and math courses. They are used not simply for solving systems of simultaneous linear equations, but also for describing the quantum mechanics of atomic structures, describe computer game graphics, for example the tic-tac-toe, analyzing relationships. Matrix is a rectangular array of numbers called elements consisting of m rows and n columns. This is said to be a matrix of order n by n. For instance, here is a 2 by 3 matrix, an example I'm going to write in the board. This is a matrix of 2 by 3, 2 rows and 3 columns. Matrices can be used to solve linear equations. Here are basis property of matrices in algebra. Basis property of matrices. They have addition, subtraction, multiplication, scalar multiplication, and transposition. Let me explain to you every single base property of matrices. For example, addition. If you have a matrix in addition is only possible to add two matrices if they have the same numbers of rows and columns. For example, if you have matrix A is equal 1, 2, 3, 4, 5, 6, and matrix B is equal -6, -5, -4, -3, -2, -1, then the addition of A plus B is equal to -5, -3, -1, 1, 3, and 5. You just 1 minus 6, 2 minus 5, 3 minus 4, 4 minus 3, and you get the A plus B matrix. We talk about subtractions. Subtraction is only possible to subtract two matrices if they are the same number of rows and columns. For example, we got the same example here. We have a matrix A, 1, 2, 3, 4, 5, 6, a matrix B, minus B, minus 5, minus 4, minus 3, minus 2, minus 1. And you're going to take matrix A minus B. You get the result is going to be 7, 7, 7, 7, 7, and 7. This is because you have 1 minus 6. You have 1 minus 6 is 1 plus 6 equals 7. Then that you get the result here. Now we have the multiplication property. Multiplication is only possible to multiply I times B if the number of columns of A is equal to the numbers of rows of B. Then if A is an n by m matrix and B is an m by p matrix, then the result X will be n by p matrix. We have an example here. Matrix A is 1, 2, 3, 4, 5, 6, and matrix B is 1, 2, 3, 4, 5, 6. There is a matrix of 2 by 3, and this is a matrix of order of 3 by 2. They have the same number of rows and columns, and the number of columns and rows. Then the matrix, the result is going to be a matrix of 2 by 2. This what you do is you multiply this one times this one, you get 1, 2 times 3, you get 6, 3 times 5, you get 15, and this is the first, when you add it together, that give you number 22. Then you just go do the same procedures with the second column. Then 1 times 2 is 2, 2 times 4 is 8, 3 times 6 is 18. Then the result matrix of A times B is equal to 20. It's a 2 by 2 matrix of elements 22, 28, 49, and 64. Now let me explain to you scalar multiplication. Scalar multiplication is a simple of multiplying each element of a matrix by a number. We have the scalar 3 and the matrix A. The matrix is 1, 2, 3, 4, 5, 6. The only you're gonna do is like 3 times 1, 3 times 2, 3 times 3, 3 times 4, and then you get the result. 3, 6, 9, 12, 15, and 18. And transposition matrix is converting a m by n matrix into a n by n matrix by flipping the rows and columns. You have matrix A is equal to 1, 2, 3, 4, 5, 6, and the A transposition is equal to the columns is going to be the columns going to be 1, 2, 3, 4, 5, 6. Okay. Also, there are special matrices, special types of matrices, such as a vector matrix is a matrix that contains only a single row or column. For example, this is a vector matrix, just a single row. Also, they have the null matrix. This is a matrix where every single element is 0. Also, we have the square matrix. It's a matrix where the number of rows and columns are equal. And finally, we have a diagonal matrix. It's a matrix, it's a square matrix in which all elements are 0 except the elements for the leading diagonal. For example, these are not 0 and the rest of the elements are 0. Okay. Also, matrix is a square matrix in which all the elements of the leading diagonal are 1 and all the other elements are 0. For example, this one is 1, this is 1, and these are 0. Diagonal is 1. If you multiply any matrix by the unit matrix, the result will be the original matrix. And the other we have the symmetric matrix. It's a square matrix where the matrix where all the elements are symmetric. For example, you have the diagonal and you have these 2 is symmetric with this one, these 3 is symmetric with this one, and the 4 is symmetric with that one. And the number 7 is a skew symmetric matrix. It's a matrix where all elements of the leading diagonal elements are 0 and the other are inverse. Okay. Now, matrix is determinant and the inverse of matrix to solve a self or simultaneous equation. A determinant is only a square array of numbers running in a pair of vertical lines, which represent a certain sum of products. For a matrix of 2 by 2, just simple the diagonal top left by the bottom right, then subtract the bottom left by the top right. Later on, I will give you an example of the 2 by 2. And also to find the determinant for a matrix of 3 by 3 or larger, this method is called expansion by minors. The minor of the 2 by 2 determinant is called the cofactor of A1 and is formed from the elements that are known in the same row and columns. Let's do an example each one. For example, to find the determinant of the 2 by 2 matrix, we have matrix of 2 by 2 of elements 4, 1, 2, and 3. You multiply diagonal and then subtract the multiplication of these two. Then 4 times 3 minus the multiplication of 2 by 1 is 4 times 3 is 12 minus 2 is 10. Now the difference of doing like 3 by 3. Okay, this is by 3 by 3 matrix is called the cofactor minus. Then you get cancel these two and then you get the cofactors here is negative 2 is 2. I'm sorry, this is the paper. Then it's negative 2, right? Then you got 2 and the cofactor is this one here. This is the matrix of 2 by 2. Now you get minus 5. You go to the second row. Then you just got this one and you get this 4 factors here. And it's 3, 2, negative A and 1. And then you do the same by the third row and column. And with the first column, then you got 4 here. And you get the 2 by 2 matrix is 3, 4, negative 1 and 1. And you just do simple multiplication and add it. And at the end, you're going to get negative 6. Now with the determinant and the Cramer's rule, it is possible to solve a system equation. The definition is if you have a matrix A, B, and C, then how you can find it with the Cramer's rule, you replace these factors here by the result here in every single one to find X, Y, and Z. Then all the coefficients here are replaced by D. Then you put the coefficient of B and the coefficient of C. When you're gonna find Y, you replace the results by the coefficients of Y and divide it by this matrix, the determinant matrix. Okay, let's do an example. Now let's solve this problem of linear equation with 3 variables using the Cramer's rule and the determinants. you have the linear equation 2x plus 3y plus c equal 2, negative x plus 3y plus 3c equal negative 1, and negative 3x minus 3y plus c equals 0. Then, like I say, you replace the result by the variable, the coefficient of the variables, and do a matrix of 3 by 3 over the determinant. The determinant we express as a triangle. Then when you're gonna find y, then you do the same. You do like replace the result by the coefficients and do the same by c over the determinant. Then let's do right here in the bottom. Let's do find x. Then x is equal, and this one times this one, then this is the determinant, right? Then it's 2 times 1 is 2 minus negative 3 times negative 3 is negative 9 plus, it's going to be plus because minus, then it's 9 plus 2 is 11. Then it's plus, go to the second one, minus that, this is minus, but you have minus 1 here. Then it's going to be 3 times 1 minus 3 times 1, but it's positive, then it's going to be 6. 3 plus 3 is going to be 6. Plus the last one, like, is 0, then it's going to be 0. Over the determinant, you do the same here. You do 2 times 11, 11. The next one, then it's going to be negative by negative 1 plus going to be the same, 6. And the last one is plus by negative 3. And it's going to be 3 by 3, 9 minus 2. It's going to be 7. 9 minus 2 is 7. Then you do the multiplication, and this equal going to be equal 4. Okay. Now the same way you find y. Let's find y here. Then y is going to be equal to, you do the same process here, like that. Okay. Then while doing the same, you're going to find that y is going to be equal to negative 3. And z, doing the same procedure, you're going to find the z equal to 3. Okay. If you want to check this, then you have to x equal 4. Then you can replace this value in any of the original equation. You can replace it in this one. 2 times 4 plus 3 times negative 3 plus 3 times 1 is equal to, is equal 8 plus, minus 9 plus 3 is equal to, this 11 minus 9 equal 2, then it's 2 equal 2. It's true. Okay. Also, the inverse of matrix is used to solve system of simultaneous equation. There are different ways to find the inverse of a matrix. The first method is called transposing. Involves the use of the terminal of the matrix after the interchange the leading diagonal elements and change the sign of the other two elements. The definition is in the board. Is A inverse is equal to 1 over the determinant of A times the transposing of A. Let me see if we have time to explain this with an example. You know, we continue in the next video. With the formula, we had a matrix of 2 by 2. Then we have to find the determinant of this matrix. We find the determinant, and the determinant we find is 13. After that, we interchange these two and change the sign of the other two diagonal. Then we 5, 2, and we change the sign is 1 and negative 3. After we have that, we plug with the formula 1 over the determinant times the transposing. Then you multiply that and you get 1 times 1 over 13 times 5 is 5, 13, negative 3, 13. Then when you multiply the matrix A inverse times the matrix A, you got the identity matrix. Let's continue in the next section with the second method. It's called the adjuncted matrix for matrix larger than the 2 by 2. Okay, I'll see you in my next video. Thank you.